Let's cover these. 6 trig ratios. Sine of theta is equal to opposite over hypotenuse, right? So this is opposite of the angle is going to be what? A. And what is the hypotenuse here? C. So sine is A over C. Cosine of the angle is adjacent over hypotenuse. So what is that ratio going to be here? B over C. Tangent is opposite over adjacent. Okay? Opposite over adjacent would be what here? Yep, opposite is A, adjacent is B. Adjacent means next to, so it's attached to. Now, the inverse, these are the basic 3 trig functions, ratios. Their inverses are what happens if you flip them over, right? So 1 over sine is cosecant. Cosecant of theta, instead of A over C, it would be what? C over A. Opposite of cosine is secant. If you flip cosine ratio over, what do you get? And opposite of tangent is cotangent. So instead of A over B, B over A. Okay? Now guys, you can find all 6 trig ratios given any 2 sides, and that's it. Just the 2 sides. Because if we know 2 sides, can't we find the third? What formula helps us find the third side in a right triangle? Yep, Pythagorean theorem. Pythagorean theorem says what? Yep. A squared plus B squared equals C squared. So if we're given 2 sides, we could find the third side by employing the Pythagorean theorem. That is leg squared plus leg squared equals hypotenuse squared. Okay? Notice I kept my A, B, and C consistent with that. So if I want to find this piece right here, this is the piece that's missing. Is it a leg or is it a hypotenuse? It's the hypotenuse, isn't it? It's always opposite the right angle, right? Hello, good morning. Don't want you to miss anything. No, don't miss any good learning. All right, so how do we plug in? What's our Pythagorean theorem going to look like here for the third side? Equals? Okay, so solve for C, please. If you know your Pythagorean triples, this one would be easier just in your head. Remember 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17. There are some Pythagorean triples that are good just to know. And those are kind of the ones you see a lot. 3, 4, 5, 6, 8, 10, 5, 12, 13, and 8, 15, 17. Or multiples of those. But 8, 15, 17 does show up. So C should be 17. So we're going to put 17 here. And now I want you to write your 6 trig ratios. I want you to tell me what sine of theta is, what cosine of theta is, what tangent of theta is. And then I want you to do cosecant, secant, and cotangent. Now, I will tell you the big mistake that people typically make here is they mix up whether sine goes with cosecant and cosine goes with secant. They try to do sine secant, cosine cosecant. Notice that the letters are opposite. Cosine goes with secant, and sine goes with cosecant. So S goes with C, and C goes with S. Not the same letter, the other one. And tangent, cotangent, nobody ever messes up. So take a sec, get all 6 of your ratios, and then we will let you check them. You get those 3, the other 3 are easy, aren't they? How'd we do? Good. You can remember sine, cosine, tangent by SOHCAHTOA, and then just remember the other 3, because if you get the first 3, the next 3 are pretty good, as long as you can get that sine cosecant relationship. All right, so now let's move on to something tougher. It says given cosine is 3/8, find the other 5 trig functions. So it gave us cosine. Notice the first thing I did. I said, okay, cosine is 3/8, so I drew a triangle. If I hadn't given you a triangle, which they won't give you on like the ACT, then you're going to need to draw your own, aren't you? Typically what they'll do is they'll say, given cosine is 3/8, what's the tangent? Okay? So you're going to have to, they won't ask you for all 5, but they'll ask you for one of them. So what's the first thing I need to do here? Find that other leg. So do that, please. And it doesn't matter which one you call A and B, as long as you're consistent. Do not make it a decimal. Leave it as a simplified radical. I know, just go. All right. What is your simplified radical? 64 minus 9 is, you're going to take the square root of that, right? So root 55, does root 55 simplify down at all? Nope. 5 times 11, neither one of them is a perfect square, so that's easy. So we're going to leave it that way, and now we're going to find, we have cosine, so we just need to find sine. I just go ahead and write them all out just like I normally would. So that I don't forget. This is root 55 right here. So what is sine going to be? Good. Root 55/8. We know this is 3/8. And what is tangent? All right. Now, here's where it gets a little bit tougher for some of you. What is cosecant? It's not a trick question. Okay, and you can't leave it that way. Why not? You can't have a radical in the denominator. So how do we simplify those? How do we get the root out of the denominator? Multiply by root 55 over root 55. There's a pattern here. It becomes 8 root 55 over 55, right? And then we could simplify, if 8 and the 55 would simplify, we could do that. What's secant? 8/3. Don't have to do anything with it. Now, cotangent is what? Okay, so 3 over root 55, which if we simplifies it becomes 3 what? Do you see the pattern yet? If we start with 8 over root 55, it becomes 8 root 55 over 55. 3 over root 55 becomes 3 root 55 over 55. And then we could reduce the outside numbers if we needed to. So there's a pattern there. You can skip the second step if you wanted. You could just flip it over and rewrite it. How are we doing? Pretty good? All right, special right triangles. 30, 60, 90, and 45, 45, 90. In a 30, 60, 90 triangle, There are ratios, and the ratios are as follows. If this is a 30-degree angle down here, and this is a 60-degree angle, if this short side is 1, then the hypotenuse is twice as long as that, so this would be 2, and then this would be root 3. You could think of it this way, instead of 1 to root 3, because it's always going to be ratios of those, x, 2x, and x root 3. Make sense? Okay. 45, 45, 90. Now, do you know where that comes from? It comes from an equilateral triangle, guys. Think about it. If you had an equilateral triangle, which means all 3 sides are the same, that means all 3 angles are the same too, doesn't it? What do the 3 angles of a triangle add up to? 180. So if you divide that by 3, what are each one of them? 60, 60, and 60. And if you take and you drop this altitude right here, this is 60, isn't it? Well, half of 60 is what? 30. And if this is 1 right here, then this is also 1, isn't it? Because it's split in half. So 1 plus 1 is, and since all 3 sides are the same, that would make this 2. And then the Pythagorean theorem would give you the third side, which is root 3, because 4 minus 1 is 3. That's where it comes from, okay? 45, so it comes from splitting down an equilateral triangle. Now, 45, 45, 90 comes from a square. Think about it. If we have a square, and I split it right here, this angle is 90, isn't it? This angle is also, and that if it's a square, then if I split that, it's going to split it into 2 equal pieces. So what are they going to be? 45 and, if this is 1, then this is also 1. And we can use the Pythagorean theorem to find the other piece, which is the hypotenuse, isn't it? What's 1 squared plus 1 squared? 2. And then if we take the square root of that, what do we get? Root 2. So there is our 45, 45, 90 is literally going to be, if this is 45, 45, terrible triangle drawing, it doesn't look like a 45, 45, 90. This is 1, 1, root 2. Or if we want to do it the same way we did it before, x, x, and x root 2. Okay? Y'all good with that? Do we understand where they come from now? Now, why am I talking about 30, 60, 90, and 45, 45, 90? Because we're going to be looking at the unit circle next time. And unit circles, all 45, 60, and 90 angles are the ones you need to know. Okay? Now, I'm going to go ahead and tell you right now, you're going to have to memorize the unit circle or figure out how. Now, next time I'm going to, some of you probably already have it memorized. I'm not letting you use the unit circle on your test. So you'll have to either be able to draw it really quickly or you'll just have to know it. Now, I'm going to be nice to you, and next time I'm going to give you a set of flashcards that give you all the basic values, and you can sort of quiz yourself for sine, cosine, and tangent of the different values in your spare time if you want, so that you can memorize them that way, or you can learn the patterns. I'll show you how to learn the patterns and what they are, so you can very easily just know what those values are, okay? I will give you strategies. Pi over 6, 0, pi over 6, pi over 2, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, and so on. Okay? Just going all the way around it. All right? And then you got to know your values. The nice thing, of course, is if you learn the first quadrant and the first quantiles, then all the rest of it's the same by symmetry. Just change the signs according to the quadrant it's in. But you still got to know where you're at. So I'll teach you some hints and tricks next time to do that. So it says find cotangent of 30 degrees. 30 degrees. Cotangent. Guys, all you have to know is this. Cotangent. Cotangent. Let's do tangent. What is tangent of 30 degrees? It's going to be opposite over what? Opposite over adjacent, is it not? So of that 30-degree angle, what's opposite, what's adjacent? 1 over the square root of 3. So now cotangent then would be what? Root 3 over 1. So it would just be root 3. So for cotangent, cosecant, and secant, you're always going to start with the sine, cosine, or tangent and then flip them over, aren't you? Questions so far? How we doing? Why don't you try one on your own? It says find the secant of 45 degrees. So if you're dealing with secant, what are you going to use instead of secant? So you want to start by finding the cosine of 45 degrees. So I want you to draw out your 45, 45, 90 triangle. And for 45, 45, 90, what does the triangle look like? Yep, 1, 1, root 2. So far, so good. So now find the cosine of one of those 45-degree angles, and then good. You're getting it. So what is cosine? Yeah. Adjacent over hypotenuse, right? So what's adjacent? Let's use this one. What's adjacent to that angle? What's hypotenuse? So it'd be 1 over root 2. So secant of 45 degrees would be what? Square root of 2. Flip it over, you get square root of 2 over 1, which is just root 2. Make sense? Okay. Now, what if we have values that are not special triangle values? This is where your calculator comes into play. So to do these, and I know you've done these before, to do these, you have to know your SOHCAHTOA. In other words, from the angle that you're given, you need to label opposite, adjacent, and hypotenuse. So for this 53-degree angle right here, what is this? What side is this? Opposite. And x is what? Hypotenuse. So what we know is we have opposite over hypotenuse, don't we? So of SOHCAHTOA, which one is opposite over hypotenuse? S stands for sine. So we know sine of the angle equals opposite over, so we just fill in. What is the angle? 53 degrees. What's opposite? Hypotenuse is, now this is like having a proportion. You can just cross multiply, guys, and divide. Now if you have a proportion, what can you do across the diagonal of the proportion? You can just multiply, but you can just swap them, can't you? Let's do this as our proportion. We're going to do these two multiplied and these two multiplied. So we have x sine 53 equals 1 times 15, which is, now how do I solve for x? Divide by, you see why I said you could just swap the x and the sine 53? You can always swap across the diagonal in proportion. So x is something. Make sure your calculator's in degree mode first, please. Check across the top. Make sure it doesn't say radians. If it says radians, you're going to get some weird, funky answers. And you're going to be looking at me like, whoa, wait a minute, I don't understand. So your x should be bigger than what value that's on that right now that you see? It should be bigger than 15. Why? What do you... Hypotenuse, and the hypotenuse is always the longest side, biggest value. So if you get something less than 15, you've done something wrong. So what did you get? All right, good. All right, now, we can do this, no big deal. What if we're given something like this? It says a competitor in a hiking competition must climb up an incline course that's 1 mile long. The course is at a 48-degree angle to the horizontal. How far above their starting point does the competitor end up? What do I need to draw first? Right triangle and label. What do I know? Where does that 48-degree angle go? Yeah. From the horizontal, this would be 48 degrees from here up, wouldn't it? Where does the 1 mile go? Yes. 1 mile, which is, what, 5,280 feet? It is. Yep. Yes. It is for real. I did not just make that up. I promise. 5,280 feet. You should know that.
I should know that.
Mm-hmm. Just like there are 3 feet in a yard.
Whoa, I mean, yeah, that's easy. But like a mile is different.
Yeah. Well, that's one that you should just kind of should know. All right. So where does my X go? How far above the starting point? Where's the X? Got 2 choices, the bottom or the side. Why the side, Carlos? Okay, which implies we're going in what direction? Up and down. So X. So label your sides. Hey. Wake up. All right. So label your sides and tell me what we're using. Sine, cosine, or tangent. Why sine? Okay, so we got opposite here. We got hypotenuse here. So we're using sine. Sine of what? 48 degrees is equal to X over 5,280. Feet makes more sense, doesn't it? We could have done it in miles. It doesn't matter either way. So if we solve for X, we get 5,280 times what? Sine of 48 degrees. Put it in your calculator and tell me how many feet it is above the starting point. What elevation do they end up at? Yeah. 3,923 point about what, 8 feet? Above their starting point. All right, now, what if we had the sides, but we need the angle? We still set it up the same way. We still need to figure out whether we're dealing with sine, cosine, or tangent. So in this particular case right here, am I doing, think SOHCAHTOA, am I using sine, cosine, or tangent this time? What'd you say? Why cosine? Yeah. From this angle that we're trying to find, adjacent and what? Hypotenuse. So CAH, right? So this is cosine of theta is equal to adjacent over hypotenuse. Now, here's the question. How do we get the angle out? How do we undo cosine? Look on your calculator and look at the cosine button. What do you see just above the cosine button? Inverse cosine. And how do we undo something? We take it. So what do we need to apply to both sides of this? Inverse cosine. And that goes away, and we're just left with the theta. So we just have to find the inverse cosine of 14 over 16. So hit second cosine, and then put in your 14 over 16, right? I like to show you these things in terms of inverses because I think sometimes we teach them to you just this is the process and we don't tell you why. And why helps you remember it better. Yeah, we usually round to the nearest degree. So about what? About 29 degrees? All right. So now, angles of elevation and angles of depression. You remember these? This is the last of the easy stuff we're going to look at today. Angle of elevation means what? Up. Depression means, so from the horizontal is where we measure. This is the horizontal, right? So from the horizontal, we are looking down here. So this would be an angle of depression. And from the horizontal here, we are looking up. So this would be an angle of elevation, okay? Notice that they are the same. Does it not make sense? I want you to think about looking at that top corner up there. Look at, if I were looking at you, you would be looking at me, wouldn't you? If neither one of us moved, if you were up there and I was down here, guys, think about this. If you were up there and I was down here, if I'm looking up at you, aren't you looking down at me at the same angle from the horizontal? These are alternate interior angles, aren't they? So we look down and we look up at the same. So if they give you an angle of elevation, you automatically know the angle of depression and so on, okay? So when we use these are almost always strictly in word problems. So you got to be able to draw the picture and know where to put that angle, whether we're looking up or down, right? Let's look at these. Example 8, sightseer on vacation, looks down. Ooh, hang on, yeah. Using binoculars. This is a more difficult problem because they're giving us what? He's looking depression, angle of depression. They give us two angles of depression, don't they? And how wide, how deep the canyon is. Feet deep, should be feet deep. Wants to know how wide the river is. We need to draw this picture. This is a typical later ACT type problem. I want you to think about it. Sightseer is on the top of a canyon. So we are standing up here, looking down. What do we know? We know how tall it is, so where does the 1250 feet go? It goes right here, 1,250 feet, right? Now, the thing we have to figure out is we've got to figure out, I'm going to do mine in colors. You know the angle of depression to the near side is here, right? And then we have one to the what? Now it doesn't tell you which one's 61 and which one is 63 degrees. I want you to tell me by looking at that picture, which one has the bigger angle? The red or the blue? Really? You're telling me that this angle is smaller than this angle. Which one of these angles is bigger? Which one's bigger? The red one is, isn't it? Think about it. If you're looking further away, aren't you looking at less of a slant? It's steeper this way, isn't it? We'll look down. Now, it said angle of depression, so really what we're thinking of is this angle here, aren't we? But what did we say about this angle and this angle? We said they're the same, aren't they? So even though it said angle of depression, I could label this, couldn't I? So which angle goes here? 61 or 63? Ah, and which angle goes here? Ah, think it through. Don't be intimidated by these problems, okay? So this is 63 degrees, and this is 61 degrees. Now, how does that help me? Guys, with that straight up and down, I have not one, but two right triangles, don't I? And what I want is how wide is the river? That's here, guys. That's this, X. I want you to tell me, let's draw these two. So we have two separate angles, triangles here. So this one's 63 degrees, and this is 1250. And then we have one that is 61 degrees. And this is 1250. How can I figure out what that piece X is? Ah, did I hear the word subtract? Yeah? What do I need to find first? Let's look at something here. I could find this, couldn't I? And I could find this, because that's this, isn't it? and that's this. So how would knowing those two pieces help me find x? Yeah, if I subtract the smaller one in red from the bigger one in blue, what's left is that x that we're looking for, the river. So can I find those two pieces right there? What would I use to find it in both of them? Tangent. I sure would, wouldn't I? How do I know it's tangent? Because this is opposite and this is... Okay, so let's call this A and let's call this B. Is that cool with you? And to find x, we want to take what? Yeah. So let's use tangent and find A and B and plug in. So the tangent of 63 degrees is going to be what? Opposite over A, right? So A is going to be 1250 divided by tangent of 63 degrees. Notice how I just swapped across the diagonal again? Does everybody see what I'm talking about? If you have a proportion, which you have here, you can just take these two amounts and swap them, can't you? It's the equivalent of cross multiplying and then dividing. You just swap them. So you should come up with a number here and come up with a number here. And then we can plug in and solve. And that's a complicated problem. That would be like the last 10 problems on the ACT type problem. So what is A? Okay, 636.9 feet. Okay. Can you then find B? 692 point what? 9? Okay. And now we're going to take and plug in. 692.9 minus 639.9 is what? It's what? 50. Okay. Make sure that's right. Let's see. 1250 divided by tangent of 61 is 692.9. So 692.9 minus 636.9. Sorry, I see what I'm saying. You're just saying 56. 636.9 is 56.0 feet. So the river is 56 feet across, right? Okay. There's the answer. Last one. Can you solve this triangle for two sides? Two separate pieces means two separate trig ratios.
Miss Duffy?
Yes.
Hey, Madison Blackwood is checking out.
Okay.
Thank you.
Good timing. We're on the last problem, I think. Okay. So see if you can solve for F and H. Your homework, if you'll notice, make sure you write down what your homework is. It's 1 through 61 odd. Please don't complain that it's not as many problems as it seems. It's 30 problems, that's it. And most of them are fairly short and straightforward, right? Okay. You'll have to do them on a separate paper. You'll be fine. Make sure you write it down. And it says solve the triangle. It means find all the pieces, not just F and H. You got to find the other angles too, don't you? Yep, I don't know why there's a blank.